Hey guys, this is Patrick from STH, and today we're going to take a look at this server right here, which is the Asus RS720A E11 RS24U. This server is actually super cool. It is absolutely jammed packed with a whole bunch of basically the newest technology that you can go get in a server. For example, this is a dual socket server, but we have two AMD EPYC 7763 64 core processors in here, which means that we have 128 cores and 256 threads. But the CPUs are not the only story, because under these three metal structures right here, we're going to get to these in a little bit, but there are actually a total of 4 NVIDIA A100 GPUs. These are PCIe GPUs, and well, this is one configuration of this system. There are other configurations as well, but in just what we have here, we have a system that can have up to 128 cores, 256 threads, 8 terabytes of memory, and 4 absolutely massive GPUs. Oh, and on the front of the system, we can also put NVMe SSDs. So the basic game plan for today is that we're going to take a look at the hardware of this server that's sitting in front of me. And we're going to go discuss all of the kind of really cool things that Asus did to go and fit everything into a server like this. I don't necessarily think that this is the absolute perfect server or necessarily even the perfect configuration for everyone, but some folks are going to think that this is like the absolute nirvana. This is exactly what they want. I am just going to mention real quick the fact that this is one configuration that the system can come in, and there are a variety of other configurations that you can get as well. So while we're going to go over the hardware performance and all that kind of stuff like we normally would, I also want to spend some time as we're going through the hardware section to really talk about how this server incorporates a lot of the mega trends that we're seeing in server design these days. There's certain elements in here that when the brown box arrived, the shipping box arrived in, the lab so we can go take a look at the server. I wasn't really expecting that there was going to be this much of, that kind of forward-looking technology and thinking about server design. But then when we opened it up, I kind of started opening up the system and looking through it, and I was like, oh my gosh, this actually incorporates a lot of the key themes that I want to talk about on STH this year. Now, we usually talk a lot about those themes on the STH main site, but I'm going to try bringing some of that into the video format for this review. And a quick ask here, I'd just like to know, if you guys think that that's valuable or not valuable, if you just kind of throw those comments down in the description, I'd appreciate it. Just like to know and calibrate that for future videos. All right, so let's start off with the absolute most basic question, which is like, how big is the server? It is a 2U server, and the depth of the server is 844 millimeters, which is, I think, just over 33 inches or so. That's actually a big deal because some other vendors, they are able to go fit more into a system, but they're doing that by extending the chassis. And what that practically means is that once you start hitting something like a 36-inch chassis or something like that, yeah, you have a lot more room in the middle because, well, you have just physically more room. But it also means that you start running into issues in terms of your racks. And so you start needing to have deeper racks. At about 840 millimeters or 33-ish inches, you're basically going to be able to fit this in the vast majority of racks, which is really nice. So on the front of the chassis, what you're actually going to see is that we have a total of 24 2.5-inch hard drive bays. Now, 16 of these bays are NVMe only, but we also have another 8 which are NVMe or SAS and SATA. For SAS, you do need to have a PIKE controller. We're going to talk about that when we get to the rear of the system. The other fun thing that is on this server, and it's just part of the server's design language, is that you're going to notice that you don't necessarily have the normal loops that you would see on the front of a server on the rack gears to be able to pull a server out of a rack or something like that. Instead, you have these little handles that fold in and out. I'm actually not the biggest fan of this design, but it is practical and I understand it. But behind those handles, we actually have the SSD drive trays. And these, I think, are actually a little bit cooler than you would maybe expect. So it used to be back in the day that you would have to go in every drive, you'd have to go screw 4 screws in. And it was just, I just hated doing that. On 24 drives, 4 screws each, that's a total of 96 screws. And especially if you have to go pull drives out and put new ones in, it's a lot of screws. And so one of the really cool examples of like the innovation in this generation and something that we're seeing on a lot more servers these days is that we have a toolless drive tray option. Now, some of these toolless options that we see in the industry have like levers that come out, or maybe they hinge in an area or whatever the heck it is. But these are actually really simple. You actually can just pop a drive out. You can see that I just popped the drive out and you just plop it back in. And that's basically servicing a drive in a system like this. Now, normally when we do these server reviews, we start at the front and we move to the rear, but we're going to do something a little different this time. We're going to go directly to the rear, and then we're going to talk about all the stuff that's going on in the middle of the system. All right, so on the back of the system, just to kind of go through a couple of the highlights, we have 2 USB 3 ports. We also have an out-of-band management port that goes to the BMC. The BMC in the system is actually an ASPEED AST2600, which is a, I guess, upgraded, newer version of a BMC versus the previous generation AST2500. It's faster. It came out a couple of years ago, but we're just starting to see that systems are starting to adopt that new BMC in this generation. And so that's something that is kind of cool that this just has that. That BMC is what provides you with all of the management interface. And if you want to have like an IKVM or feature or remote mounting, you want to do firmware updates, all that kind of stuff, you can do that using that BMC. Now, we're going to talk about the networking as we get into the server a little bit more, but the one feature that you probably aren't really used to seeing on a lot of systems is the fact that we have this Q-code LED readout. And this actually goes and will go through the post process. So if there is an issue with the motherboard, say that you have a PCIe card that maybe isn't working well, or maybe you have an issue with a DIMM or something, you can actually see the postcodes of a server from outside the server. So if you're looking at it, you can actually see what's going on. And along those lines, we also have a VGA port as well, because of course we do. Now, the rear of the system, you're also going to see that we have a number of PCIe slots. Well, we have like basically 2 that you can see on the middle and on the left-hand side as we're looking at from the rear. But then the other side, on the right-hand side, you're just going to see a fan. Now, this is actually not a standard offering on this. This is if you do go put some high-end GPUs like the A100s that we have in here, you can add a fan to aid in cooling on this side. Specifically, the reason that's there is because, as we're going to see, there are actually 2 A100 GPUs, and so that provides a little bit more airflow, which helps with cooling and therefore performance. Now, this is the configuration that we're testing. However, there are other configurations, and I think you can get up to like 9 GPUs or accelerators in a system like this. And there are different riser options. You don't necessarily have to have that fan, so this can just be normal IO slots. Having all those extra slots does require different risers and stuff than we have here, but that is an option, and you can actually see some photos of what that looks like. If you were to go to the ASUS website, they actually have pictures of that there. All right, so let's start with the big system that we have here. And what you're actually going to see is that we have a total of 4 large fans that are sitting in the middle of this chassis. You can see that I'm going to pull a little fan out here. These are big Delta units. Something that you're going to notice is that these things are like this like bright green, like day glow green color, kind of like you would see all over the place in the 1990s. And the reason that you're going to see that color on these as well as some of the handles here is, well, actually a pretty simple reason. Those are the main touch points. So the points that, if you were to go service the system, those were the places that you touch. And using these different colors to note the points that you should be handling when you're opening the system and servicing the system is something that we didn't see on, servers like this in this class, a couple of years ago. But nowadays we are seeing it, and it is just kind of becoming an industry standard. Now, normally this is where we go to the CPUs. But in this particular server, we have these just giant metal things that I had absolutely no idea what they were at first or why there was this giant metal thing here. But I think I want to talk about that before we get to the AMD EPYC CPUs. So hopefully we have a photo, and I'm just going to show you what one of these things looks like. What you basically do is you hold the handle on this side and you pull it out, and here you go. That is an NVIDIA A100 GPU. Now, if you saw what I just did on camera, and the reason I'm doing it from this angle is just so that you're able to see it really easily, is the fact I just literally pulled this thing out just using the handles. And the reason for that is that this is almost a contained unit that is actually in the system itself. It's not necessarily like a PCIe riser where like you have to go kind of line up and make sure that, the Goldfinger slot is all aligned properly and all that kind of stuff. This is actually just kind of a cabled unit that sits in the system. Now, there are a couple features that you probably wouldn't notice if you were just looking at this online. For example, we have a GPU power connector, which is kind of pretty standard. But on the other side, you're going to see that we have other power connectors on the bottom of this. And that power connector is actually important because that will go and power the fans that sit. There are actually 2 little fans that sit in this section right here. And that provides airflow and redundant airflow to the highly expensive GPUs that are in here. I am just going to note that we do have the A100s in here, but there are also options if you want to go put like AMD GPUs, or if you want to put like Xilinx FPGAs or some other kind of accelerator, you can totally go do that in a system like this. And that's one of the really nice things about the PCIe Gen 4 flexibility. Now we talked about the power and how this is a self-contained unit, but I also want to just talk about, well, then how is it getting data connectivity? Well, and the way that it's getting it is actually that they're on the bottom here, there's actually 2 PCIe cables. And the big deal there is just the fact that by having this be cabled, we get a lot of flexibility on where this GPU can be put into a server, because we have the cooling, we have the power, and we have the data being, pulled into this assembly. We don't necessarily need to be limited by where you can go put a riser in a system. With PCIe Gen 4 today, and then in the future with PCIe Gen 5, the practical limits to how far you can go you can run a trace from a CPU to an accelerator like this GPU, those traces and practical trace lengths are getting a lot smaller or a lot shorter. And so something that we are seeing is that you can actually get better signal quality, even if you go through a connector or two, by going through a cable. And so something that we're going to see more of in this generation of servers and then in future generations of servers, we're going to see more assemblies like this exact one that we're looking at now, where you have the GPUs that are on a cabled PCIe connection. And that allows a lot of flexibility in how you place the units, but also allows you to have longer cable lengths. So both of these assemblies, the one closest to me and the one in the middle, those are both assemblies with a single GPU. This further out one is actually one that has 2 GPUs in it. And that's actually the reason that you have this fan on the rear of the unit, so that way you can cool the 2 GPUs that are in this partition. All right, so under the GPUs, and now that we've seen how 4 GPUs fit in here, let's get under the GPUs and let's talk about what's going on underneath. Now in the system, there are airflow guides, and those airflow guides take air from the bottom portion of where the mid-plane fans are pushing, and they push it to the CPU heatsinks. In this configuration, we have 1U heatsinks, and so you can think of it like we have 1U heatsinks on the bottom, which is really kind of our server part, while we have airflow for the accelerators on the top of the system. We're starting to see this kind of dual zone configuration on more systems as the power levels go up. Okay, so getting to the CPU side of things, this has 2 AMD EPYC 7002 or 7003 series CPUs. We have 7003 series CPUs in here, and we actually have the 7763. We have a video that we'll link in the description on the AMD EPYC 7003 Milan series, and we also have a review of the 7763s on the STH main site that we'll also link in the description as well. Each CPU gets a full set of 8-channel memory and 2 DIMMs per channel, which gives us 16 DIMMs per CPU socket, or 4 terabyte capacity using 256 gig DIMMs per socket. And then we have 2 sockets, so you get a total of 32 DIMM slots in a system like this. Our test configuration came with half of the memory channels populated, but when we actually did our testing, we put in extra DIMMs, so that way we would have a full set. Something that I did want to point out just very briefly here is just the fact that if you think of this 19-inch rack, these processors with the 32 DIMM slots actually take up basically the entire width of this 19-inch rack. Sure, there's a little bit of extra room for cable routing and such on either side, but basically, we're basically at the point where these are now taking up the entire width of a rack mount chassis. Years ago, when we had the Intel Xeon E5 generations, we only had 4-channel memory, which was half as much. And so you could go and put systems onto platforms like ATX or eATX platforms. But nowadays, most of the high-end servers actually use custom form factor motherboards. And the reason that they're using these custom form factor motherboards is just simply the size. It no longer makes sense to go and make a lot of motherboards that can still fit in those old legacy sizes. When you want to create a platform and you have way more expensive CPUs, you have way more IO, way more memory slots. And so as systems get bigger, the motherboard has to physically grow in size to be able to provide all the IO and slots that are necessary. And so because of that, we are seeing this trend in the server industry towards these custom sized motherboards. So that's just another industry trend that I wanted to cover in this system. Okay, now other features on the motherboard, the big one I would say is that we have 2 M.2 SSD slots. And the nice thing about that is that if you want to have something like boot media and you want to have M.2 boot media and just put it in one of these slots and mirror it, instead of having something like using these higher end or I guess higher value hot swap bays up front, you can totally go do that. These days, M.2 storage is pretty reliable, it's fairly inexpensive, and it's really good for boot applications. And so that's why this type of solution is very popular. We also have our ASPEED AST2600, and we have a micro SD slot, which is just kind of a trend on servers that we've been seeing for years. But what we have under this middle section is actually another riser. So if you remember on the one that's closest to me, well, we have the CPUs across and memory across all this area, but we have the power supplies that sit under this unit. We have 2 GPUs, so that kind of takes up the full chassis width over here. But this one we have 1 GPU, so underneath we actually have another riser, and that riser is super important to the system. When we're going through the rear of the server, I talked about, well, how we're going to go talk about networking later, and that's exactly what we should do. There is a little networking slot, and there's actually an option in the server that you can either have quad 1 gigabit Ethernet, which uses the Intel i350, or you can have an Intel X710 dual 10G base T networking, which is what we have here. You can see that these are on little, custom riser slots, and that's how you get your networking. On this riser assembly, the other main part is a low profile PCIe slot. And this low profile slot is interesting. Here in our particular test configuration, we have an Asus Pike 2 card. Pike 2 or Pike is just their controller. So their SAS controller family. There are HBAs or more HBA type, and then there are more RAID controllers. Here we have SFF8643, I think, connectors that go into that, but you can also use these same cables, plug them directly into the headers that are on the motherboard, and just use your front ones as NVMe or SATA, rather than having SATA, NVMe, and SAS connectivity. If you want SAS connectivity, you need to have this Pike 2 controller. I mentioned before that I think not everybody would configure a system exactly how this one is configured, and I think that's a good example. Like, personally, I would just use NVMe storage these days. Price-wise, it's not really that much more than SAS or SATA drives. And so I think that makes a lot of sense. And if you did that, that frees up your low profile slot, which is super important in a system like this. Since our onboard networking is only quad 1 gig or dual 10 gig Ethernet, that isn't necessarily like a ton of networking, especially for a system where you have 4 A100 GPUs and, really high-end CPUs, AMD EPYC CPUs as well. Personally, I would probably use something like this, which is the Mellanox Bluefield 2. That's NVIDIA Bluefield 2 now, because Mellanox is acquired and we don't say Mellanox anymore, even though we all say Mellanox. Yeah, that is happening. But this is a dual 25 gig Ethernet adapter, and it also has an ARM processor with 8 gigabytes of memory on it. And so you can actually go run, like, this actually runs Linux, so you can run Ubuntu or something like that. And this can be used to go and do all the provisioning and high level provisioning and presenting things like NVMe over Fabric to the server itself. It also has a lot of the crypto offload and acceleration. And so I think that makes a little bit more sense as a NIC versus the 1 gig or 10 gig Ethernet, especially when you get up to this level of configuration. This is a very high-end configuration for this server. So that's personally what I would do, but there are a lot of people that would be fine just as is. Now, of course, if you don't have all of this GPU infrastructure in here, what you can get is you can use other PCIe NICs. You could also potentially use like a dual slot FPGA based smart NIC or something like that in here. The other option that you have is that there are ways that Asus has that you can actually go put an OCP NIC 3.0 into a slot in this system if you're configured properly. And so there's a whole bunch of different options that you have in a system like this. And that's just frankly one of the challenges of just being able to show you like one configuration and not like every configuration possible. Frankly, we just don't have enough time to go through all the different configuration permutations because that would just take forever. But speaking of configuration options, that does kind of bring us to kind of one more mega trend that I just want to talk about, which is really the fact that this is designed for PCIe accelerators. PCIe accelerators are very useful because it allows easy swapping to different types of accelerators. For example, these A100s have a cousin, which is an A100 and an SXM4 package. The NVIDIA SXM4 GPUs in this generation are either found on the 8 GPU HGX platform or they're found on the 4 GPU Redstone platform. Those subassemblies with all GPUs and the PCB and all that kind of stuff are actually sold to NVIDIA's partners as, kind of complete units. And so what this allows you to do is have something that's different. I mean, you could have 2 GPUs in the system and then use other types of accelerators or network cards or whatever you want. Whereas if you go to something like a Redstone platform with 4 GPUs, you kind of get locked into you're really just going to want to use those 4 GPUs. Also, if you were to have one of those 4 GPU Redstone systems, they tend to use a lot more power. And the other side to it is that you get kind of locked into the NVIDIA ecosystem. In the future, we're going to have the Open Accelerator modules, and that's going to be an entire, ecosystem. But right now, if you go get a NVIDIA specific ecosystem and you want to go put like a next gen or current gen AMD GPU or Xilinx FPGA, you're just kind of stuck. And so I think that something like this is actually really interesting. It is pretty uncommon to see organizations go and pull CPUs and memory and stuff like that and upgrade to new generations. I mean, there just aren't going to be people that go out and, upgrade from DDR4 2933 to 3200 that often, or upgrade from like the EPYC 7742 to the AMD EPYC 7763. It's just not going to be overly common. But what is more common, especially in the AI accelerator area and other areas of acceleration, is that the acceleration generations tend to not jump by like 30% generation on generation. A lot of times you're going to get, 10x performance or 3x performance, 2x, whatever it is, but much larger jumps when you upgrade accelerators versus CPUs. And so having a PCIe system like this is still one of those things I always ask people, like, OEM, is that going to just be what we're all going to use in the future? And everybody says, well, it is going to be a big deal, but PCIe is still going to be very prevalent in a lot of areas because you have the ability to easily upgrade and you have a lot more of that kind of interchangeability that you don't necessarily get when you get to the more custom form factors. We are going to have a review of one of the Redstone platforms in the future, but that's the reason that you get a PCIe GPU like this. In terms of performance, we saw actually really good AMD EPYC 7763 performance in there. And these are really the high-end 280 watt TDP CPUs. So that also means that when we kind of look down the stack, we also see that we get pretty good performance as well. Something that we did was we actually compared this system to the reference AMD Daytona platform, as well as the Dell EMC PowerEdge XE8545, which is a Redstone platform. And we found that overall, this was about on par. They were all pretty close. Let's just call it what it is. They're all pretty close, but this one was probably a little bit faster than the Dell platform, which was actually a little surprising. But the point is that if you have 3 systems with the same CPUs and they all perform about the same, even if you have a very high-end GPU configuration like this, that's going to use like a kilowatt or something like that, that is a good indicator of the fact that this system has enough cooling for all the components in it. We did the same exercise comparing not just the CPUs, but also the GPUs. So we took the A100 and we saw, how that compares to another system. And we got the same basic performance, even in a, another GPU system. So it seems like we are getting the full performance out of this platform. That is kind of what you would expect, but we just wanted to validate the fact that we weren't losing any performance given this density and this configuration. And it turns out that ASUS did a good job of making sure that everything stays cool and is able to perform well. All right, so let's talk about power consumption. Now, there are redundant power supplies in the back of the system. These power supplies are 2.4 kilowatts each. Now, you might be wondering, why would you need a 2.4 kilowatt power supply that's an 80 plus titanium rated, so high efficiency power supply in a 2U server like this? And the reason that you have these is actually that the GPUs, they can use about a kilowatt. Let's call it about a kilowatt. You also, when you have a system, and just generally what we use internally for a dual AMD EPYC 7763 system, like complete system without the GPUs, we would usually use somewhere in maybe the 900 watts to 1 kilowatt range. And we really would use that as our sizing for a, just kind of normal server. So if you kind of put those two together, you say, well, you have about 1 kilowatt of GPUs plus you have about 1 kilowatt of server, and that kind of gives you your 2 kilowatts of need. There's an old saying that's, you can't judge a book by its cover or something like that. And I have to say that when this server originally arrived in our lab, I was like, okay, well, there's a 2U dual AMD EPYC server. Okay, that's, I guess, cool. But as I looked at the server and I tore the server apart to go and kind of show you in the audience and those on the website, what I really noticed was that ASUS really has a lot of, I guess, forward-looking engineering and thinking in how they design this server. And we are looking at really kind of the higher end configuration, but I do understand, how a the 9 PCIe slot version of this would go. And I think that it makes sense how they designed this entire system. Just personally, I don't think that this is the perfect configuration for everyone. I think some folks are actually going to prefer having some more PCIe slots. I think that could make sense as well. But at the same time, I think that just the fact that this platform, the RS720A platform, has so much flexibility, it actually makes it pretty useful. But as always, I'd love to hear what you guys think, so feel free to drop some comments in the description on what your thoughts are on a server like this. I think it's super cool. And hey, if you made it this far and liked this video, why don't you give us a like, click subscribe, turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.